Now we are going to see about irrational numbers. Rational numbers means the number can be written in the form of p by q, where p and q are integers and q not equal to 0. If it is irrational numbers means it cannot be written in the form of p by q. So some examples of irrational numbers are root 2, root 3, root 15, pi, and binary numbers which are in decimal format, and root 2 by root 3. Again, these two are irrational numbers, so the result will be an irrational number. Let us see the theorem. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. So how they are going to prove? Let's consider the prime factorization of a as follows. Like a equal to p1, p2, etc. up to pn, where p1, p2, etc. up to pn are prime numbers, not necessarily distinct numbers. So therefore a square will be squaring on both sides. We get a square equal to p1, p2, etc. up to pn multiplied by p1, p2, etc. up to pn, which is nothing but p1 square, p2 square, etc. up to p square n. We are given that p divides a square. Therefore, from the fundamental theorem of arithmetic, it follows that p is one of the prime factors of a square. However, using the uniqueness part of fundamental theorem of arithmetic, we realize that only the prime factors of a square are p1, p2, etc. up to pn. So p is one of the values, prime factors, p1, p2, etc. up to pn. Now since a equal to p1, p2, etc. up to pn, p divides a. So this is the proof for the theorem. In the textbook it is given as the theorem as square root of 2 is irrational. So they are going to prove how square root of 2 is irrational. So for that we are going to assume that square root of 2 is rational, that is as a contrary, that is opposite. We are going to consider square root of 2 is rational. We can find the integers r and s not equal to 0 such that root 2 can be written in the form of r by s. R by s, this is the rational number. Suppose r and s have a common factor other than 1, then when we divide by the common factors to get square root of 2 equal to a by b, where a and b are co-prime. What is meant by co-prime? So these integers a and b does not have a common prime factor. So by multiplying b with root 2 equal to a, this equation will be written in this format, and we squaring on both sides we get 2b square equal to a square. Therefore it means 2 divides a square. Now from the previous theorem what we have seen, it follows that 2 divides a. We can write a equal to 2c, that is 2 already dividing a, and again with some integer we are writing it as a equal to 2c for some integer c. Now substitute a equal to 2c in this equation, 2b square equal to a square. So we get 2b square equal to 4c square, that is b square equal to 2c square. This means 2 divides b square and also 2 divides b. Again using the theorem 1.2, p equal to 2. So a and b have at least 2 as the common factor. So this contradicts the fact that a and b are co-prime numbers, right? So this contradicts the fact that a and b have no common factors other than 1. This contradiction has arisen because of our incorrect assumption that root 2 is rational. So we are going to conclude that root 2 is irrational. Similarly, another example, root 3 is irrational. So let us assume to the contrary, root 3 is rational number. Then we have the integers a and b, which is written in the form root 3 equal to a divided by b. Suppose a and b have a common factor other than 1, then we divide the common factor and assume that a and b are co-prime. Okay, so b root 3 equal to a. This equation root 3 equal to a by b becomes, b will go to the left hand side, so b root 3 equal to a. Squaring on both sides we get 3b square equal to a square. Therefore a square is divisible by 3. This means that a is divisible by 3. We can write a equal to 3c for any some integer c. Substituting a equal to 3c in 3b square equal to a square. So we get 3b square equal to 9c square, that is b square equal to 3c square. Again b square is divisible by 3, which is nothing but, as per our theorem, b is also divisible by 3, considering p equal to 3. Therefore a and b have at least 3 as a common factor. This contradicts the fact that a and b are co-prime. This contradiction has arisen because of our incorrect assumption that root 3 is rational. So we conclude that root 3 is irrational. So next we will see what happens if there is a rational number and irrational number. If we add it or if we subtract it, what will be the result? So if we add a rational number or with irrational number, the result will be irrational. Again, the product and quotient of a non-zero rational and irrational number is, again the result will be irrational number. So we are going to see these two cases in example. Example 6, show that 5 hyphen root 3 is irrational number. So let us assume to the contrary that 5 minus root 3 is rational number. So if we decide that this is a rational, if we assume that 5 minus root 3 is a rational number, so that we can write 5 minus root 3 in the form of a divided by b. These two are co-prime numbers where b not equal to 0. So by simplification we get 5 minus a by b equal to root 3. Rearranging this equation, again we get root 3 equal to 5 minus a by b, which take LCM as b, we get 5b minus a divided by b. Since a and b are integers, we get 5 minus a by b. This equation is rational number, and so root 3 also rational. In the previous example we found that root 3 is irrational number, so this contradicts the fact that root 3 is irrational number. So this contradiction has arisen because of our incorrect assumption that 5 minus root 3 is rational. So we conclude that 5 minus root 3 is irrational number. Next example, 3 root 2 is irrational number. We have to prove that. So let us assume to the contrary that 3 root 2 is a rational number. This means that 3 root 2 equal to a by b. We can write in this format where a and b are co-prime numbers, b not equal to 0. By simplification we get root 2 equal to a divided by 3b. Since a, b, 3 are integers, so a by 3b is a rational number. If that is a rational number, then root 2 also a rational number. But this becomes contradiction to the fact that root 2 is irrational number. That is the theorem we have seen in this chapter. So we conclude that 3 root 2 is a irrational number.